Hi, everybody. Okay, let's see. Situational, situated. It's situated. Good. Let's turn off this. Okay. Already. I'll be ready in a minute to do screen share. And I would have got first today. We're really quiet today. 14 people. Austin, go for it.
Hey, so I had a question about sets. So I've seen like online somewhere it says like it's more efficient to see if an item is inside a set versus like an array list. But based on the way we implemented in class, it was like an underlying array. So I was wondering, is there a different way they implement it in the standard?
You have predicted the future quite aggressively. So we are going to, in this week right here, week 7, talk about many different other set implementations. So it's coming. It's actually a really deep question, by the way. It's probably the most interesting and deepest part of our course is the different set implementations that are out there, or equivalently a map implementation. We'll talk about maps later. They're just the same thing as dictionaries, but yeah, there are many, many philosophies, and we're going to talk about like 3 or 4. So, yep. Great question. What's next? We got 16 people today, so, you know, don't be shy. Brian.
You said that the advantage of using comparable is that we don't need to create a max function for each class we want to take the max of, but we still need to make a comparator.
Yeah, we still need to make a comparator for them, but the good news about that is the logic of a max function. You don't have to keep rewriting that same like function, right? You don't have to do this thing where you're iterating over a collection or something. The other thing is there's many other things you might do with a comparator other than just a max function. You could write a sort function, for example. So if I look at arrays.sort in Java, there is a method which takes a comparator somewhere in here. There we go. Nope, that's not right. There we go, yeah. So we can sort an array, and then we can provide a comparator, and then that will sort it. So it allowed them to write a general purpose sorting function.
Right. And so comparable also has built-in max functions, right? Will we need to pass?
Well, if you have comparable objects, then yeah, similarly, if you have a collection of comparable things, so if I look up like a, let's say, navigable set in Java, which is a different type of set than the basic set we talked about in class, it only works on, let's see what's called sorted set. Okay, anyway, the items in a navigable set should be comparable, and it lets you do things like give me the greatest element in this set that is less than or equal to the given element. So that's another example. If you have comparable items, it allows you to have operations like that. Does that make sense?
Yes. And can we pass in any comparator we want into a max or min function or sort function?
Yeah, you can pass any comparator you want. It wouldn't work for this because this doesn't take this particular set thing I'm showing is a comparable based piece of technology, but arrays, yeah, you can put any comparator you want in here. So it could be, you know, if we did sort, like if we do, in fact, let's write one real quick. That's weird. So we're gonna use arrays.sort. I don't know, it seems fun to do. One sec. Is there anything here that's bad to show? No, everyone's taking the midterm. All right, cool. One sec. Let's open our lecture code. By the way, I write midterm 1 in this class is kind of fun, where I just like sit down and think about like a cool thing I want to code up, and then I do it, and then I cut it down to its essence, and then make you guys do it. It's the most fun midterm to write. Okay, let's see. Although midterms take so long. Oh, and by the way, sorry about the Cal student question with that example. I don't know how that happened. It's funny because we have like a pretty rigorous testing procedure where the test goes through like a dozen plus TAs, like multiple phases, and just nobody looked at that piece of copy because everybody knew what it was supposed to do. And so when we got there and people were confused about it. I think it might end up being a mess when we grade, but yeah, you may remember that code that didn't quite make sense. Yeah, that was my worst test mess up in a long time. So sorry I had to be part of it.
Well, it works just as well as the actual Cow Central, so.
That's good, thank you. Let's see.
Are you showing the code?
Not yet,
right there?
I'm about
Okay.
to. Let's see, we're gonna do a that's really good. All right, let's see. Weird number thing. All right, so in weird number thing, I'm gonna create a comparator. So public class. I guess we actually let's do another new class. Let's call it like a 7 count comparator. Okay, so this is a comparator. It implements comparator integer. So it needs to have a public, actually I can hover over and it'll tell me, you need an compare TT method. Okay, great, I'll do it. Int compare integer A, integer B. Okay, so what I'm gonna do is A to string, string SB is B dot to string. Then I'm gonna do SA dot count. Alrighty, how do you count the number of things? Write code that does this? All right, whatever.
Char at.
Yeah, I mean, I wanted to get the total count of the number of 7s. Is there a built-in method that does this? I don't think so. Okay, I guess not. All right, I have to be lazy. Int count A equals 0 for character C in SA dot to car array. I think that's the thing I can do. I'm kind of cheating. It's not a way you would ever write code, but count A.
Doesn't char at work if you wanted to iterate over a string?
Yeah, you sure could. I just wanted to do this because he wants to do that car thing. I'll do it. And it's more natural to you guys. All right. Actually, I'm gonna write a helper function. So private int 7 count A string S equals integer dot to string A. And I'm gonna do for I equals 0, I is less than S dot length. You've done a lot of questions for me. This is what you're gonna get, me going on random excursions. If S dot car at I is equal to 7, then we will do count plus equals 1. There you go. That's my count of the number of 7s. And make sure I didn't screw anything up. So let's also write ourselves a unit test. Public int or public void test 7 count. Int. Real lazy. Okay, that should be good. All right, I feel like that's a pretty good testing set. Yeah. And what is missing? Oh, I have to write my. Okay, compare integer A, integer B, return 0 for now. Just gonna run my test. Okay. Make sure my 7 count works. I do this for real when I write code, by the way, all the time. It's not just for show. There's a bug. 6. That's surprising. It's a bug. How'd this bug happen? Oh, is this too big to be an integer? Octal integer. Oh, funny. Okay. Ha. In Java. You aren't gonna like this. This is not the number I put in. Okay, thank you for warning me, Java. Hold on, let me show you what I've just done. All right, I'm gonna print this number out. You're really not gonna like this. Okay, when I run this line of code, that number is actually the number 1674809.5, just written in a different way. If you start thing with a 0, you're in base 8. So in other words, if I take this and I look up and base, sorry, base conversion. Okay, I'm gonna share my screen. We're just going on a weird space, but if you go from base 8 to base 10, you get this number. Anyway, all right, so Java has the ability for you to specify base 8 numbers. Why would you ever want to do that? I don't know. I don't remember. I haven't had to specify something in octal in a long time. I probably did back when I was more an electrical engineer, but I haven't do that in a while. Okay. Yeah, right. Okay, so it's 7. Anyway, okay, now I'm gonna run this. Actually, not that one. Okay, so it wasn't a bug in my 7 count. It was a bug in my test. It works. Okay, now lastly, we got 7 count. We feel comfortable, so now I'm just gonna do 7 count A minus 7 count B. I'm pretty sure that one works. Okay, so now this is what I wanted to do all along. I need to make an array of integers. So let's do and A equals 1, 2, 3, 4, 5, 6, 7. Oh, no, sorry. 1, 3, 65, 88, 7, 126, 177, and that number. And all right. So if I do arrays.sort A, and I give myself a new 7 count comparator, what does this thing return? Oh, it needs to be type integer. Does this work? Okay. Required type T's. I need T's. What's happening here? Hold on a sec. I'm confused myself. You were supposed to give me. Oh, I didn't say what type. It implements comparator of integer. Okay. Anybody spot my bug?
I think you're missing a semicolon on the line 37.
Oh, maybe. I couldn't see it. Right. I'm not sure I can even do this. Let's find out. Oh, you know what? It could be an int array. Oh, we're running into an interesting type issue. Oh man, I thought I was going to show you something super cool, but in fact, okay. Before I fix this, any questions about what I've done so far? Oh yes, should have wrote tests for those tests, huh? Okay. Comparator. All right. I see. 7 count comparator implements comparator of integer. Okay. And here I have an array of integers. All right, we're going to go to Papa Google. Well, so the thing is, it's not yelling at me about this. Actually, there's a warning over this. A red. Yeah. Okay. I could turn it into strings, but that's no fun. One sec. I'm Googling and you can't see me. Okay, one sec. This is an interesting one. Oh, are the arguments to sort reversed? I don't believe so. Yeah, a comparator needs to be something that can compare superclass. This is basically giving you a little more flexibility. This is something called a type wildcard, not something we've talked about. Oh, you can't actually see my screen. Sorry. Yes, I was looking at the method signature. So this is the array, and this is the comparator. And this is basically giving, this is a type wildcard, so it doesn't have to literally be an integer. It could just be anything that's a superclass of integer. So we should be good. Okay. Oh, sorry. Forms to Oh, I don't want to use lambdas. Okay. Use dot sort. Oh. Man, this is lame. Okay. Thought I would get a quick Google hit. All right, so class comparator. It is a comparator. It has a compare function. I'm trying to sort it. So the thing I'm a little surprised by is it's yelling at me that a 7-count comparator is not a comparator of the thing that I'm passing in. But it is. I said so, right? Okay, I feel like I'm wasting your time now at this point. Let's do the lame thing then. All right, here. Let me just try something real quick. Raise.sort A. Fine with that. Here, somebody have a suggestion. Let's see. All right. Implement a generic comparator. Comparator of integers. I am curious to see what happens if we take away the type. What is it going to tell us now? No, then it's unhappy because then it needs to match here. Huh. Oh, that's so funny. All right. I'm usually pretty good at doing these Java syntax things. Yeah. Okay. All right, hold on a sec. Arrays dot sort integers Java. This is what I need to do. Oh, I need to pass a comparator. I am doing that. Oh, I don't want to do streams. I don't want to do lambdas. I just want plain old Java 8 style. We need to go find our old post. Still lambda. So weird. How am I failing so hard here? Oh well. Okay, I'm gonna leave it here and just leave the embarrassing video on the internet in case people have questions other than this. Go ahead, Noah.
All right, so I had 2 questions.
Yeah.
One was for equals in the project.
Yeah.
So I remember in lecture we were comparing sets, right? See if they're equal.
Yeah.
But in the project we're supposed to compare decks, and like specifically on the line where it says like o.getClass equals other.getClass or something. Like I was struggling to figure out how to make that work for decks because like you could be comparing, for example, like an array deck and a linked list deck, right?
Yeah.
So I was wondering, like, is there like a get interface or something like that?
Oh, yes. Did we not mention instance of? Ah, interesting. That's a funny oversight. Okay, one sec. I'm gonna not share my screen for a moment. Open up a solution where you can't see it. So yes, I can see what you're running into because they need to be decks. Sorry, if one's an array deck and one's a linked list deck, then you're gonna run into trouble. I'm so surprised that this didn't come up whenever we're talking. So the way I do it, which you can't see, is here, I'm gonna put it in chat, and then I need to add this to the spec. So what you're looking for is that. Yeah, but I haven't taught you instance of. It's supposed to be in the spec because it's not in the lecture. So it's a variant. One of the goals for this was we talked about equals in class. I wanted to introduce instance of on the project, and somewhere that didn't get put in the spec. Thank you, Noah. You just, yeah. Thank you, Consuelo, for also noting it checks against nulls. Yeah.
Okay.
One of the slides that instance of was out of scope. You know why? Because the project was changed this semester, and that is no longer the case because the spec was supposed to introduce instance of. Okay. Let's see. Where does it say instance of? Is that a spec? Do you know where that said? Right, Bryant. Hey, Bryant, do you know where it says instance of? Is that a scope? Okay, yeah, go for it. Thank you so much, Noah. All right, got to fix that real soon.
Yeah, and then my other question was like for iterator. I don't know, maybe it was an oversight, but for the next method, I don't know, because like I had a generic return item, and I was just kind of like getting it using the get method. For some reason, it's telling me that like the return item is of type T and it expects type T, but then it's like not compiling.
My guess is that you have an extra braces T somewhere. So let me look at my solution again in the iterator. What you don't want is, let's say you have an inner class, like deck iterator. That, which I just put in the chat, will work fine. Actually, I'm gonna do this on the screen in case anybody's watching this later. And I should probably add this to the slides. Okay, so I'm gonna add it to the common points of confusion. And let me share my screen. Okay, so slide needed on instance of. Gosh, I can't believe we didn't fix that. All right. And so here we have, why am I getting T expected type T and iterator? So if you have, or make sure your inner class looks like not, oops. So check this real quick. That's my guess as to what the problem is. That you're actually defining a new inner class T.
Oh.
Or sorry, you're defining a new type parameter T.
Yeah, I think that was the problem. Thank you.
Okay, cool. Yeah. See what I'm saying? I know this type stuff pretty well, so I'm a little surprised I can't sort an array of integers. All right. No, is that it?
Yeah, that's all.
All right, Arun.
Yeah, I had two kind of related questions about the project. So when I override equals, the IntelliJ checkstyle plugin complains that I haven't also overridden hash code. So
yeah,
what's hash code doing? Do we have to?
No, you don't know what hash code is, so it's fine. If you were, so in, this is a little preview, but the equivalent of a Python dictionary in Java, if you've not heard of this, is called a map. So a map goes from like, you know, integer to string, and you might do something like m dot put, or actually I'll do string to integer. So you can do things like m equals new map. Can't actually do a new map or whatever. So if we do input like Tokyo, or like however many people there are in Tokyo, 24 million, say, I don't know, metro area. And then we do Oakland, whatever. It's like, that's the kind of idea behind a map. Oakland, I don't know what it is. How big is Oakland? Let's say 800,000. Smaller than San Francisco, 600,000. Okay, anyway, you build maps like that. Now, it turns out that in Java, the most common type of a map that people use is a hash map. And hash maps, have the feature that they fail spectacularly if the key is overrides equals, but not hash table, or equals, but not hash code. So in other words, if you did a map from deck to integer, m, and then you did like m dot put, well, if you did deck array deck d equals new array deck oh wow, this is really ugly, integer. If you did something like this, then added, or then you put d to 500 or whatever, like you're just mapping this deck to the number 500, it won't work. That's nothing you would ever do, so we don't care. That's more than you wanted to know, but that's what it's worried about. It's worried that someone is going to try to use a deck as a key in a hash map, and it won't work. So that's what they're warning you about, but we don't know what any of that means yet. So don't worry about it. Here, watch this. TLDR. Don't worry about overriding equals, or don't worry about the IntelliJ warning about overriding equals, but not hash code. Happy?
Yep.
Cool. All right. Sorry, I like to over-explain things sometimes. Noah, is your hand up from earlier, I assume?
Yeah, sorry.
Oh, no problem. Sandra.
Hello, Professor.
Hi.
I have a trivial question about if we declare a variable to be static, does that mean we cannot alternate its values in instance method calls?
What do you mean you can't alternate its values in instance method? Oh, you can alter, like you can change it, sure.
So like in the test, there's a question like what's wrong with this code? Why wouldn't it run? I'd assume it's because size was declared to be static, right? And what's the reason for like we can't, do we have to invoke it using class name, like class name dot size?
You can invoke it without using a class name. For example, in the let's see, where's an example? Somewhere in this lecture. This one, yeah. So if you have, maybe I should grab it from the discussion worksheets. Where's the, I'm gonna find this, not the right one. Sorry, no, it's actually earlier. Right, let's see. Oh, it's not used in there. Oh, rats. Okay, so it's not showing on the slide. Okay, hold on. Sorry, I'm gonna go dig through, trying to find the right example then. So you can access it without. Here we go. Yes. Okay. Right. So this is trainer, and yeah, here we go. So you can access instance variables using a specific instance name. It's just that there's one single variable that they're all shared by.
So in this case, we're using an instance name to invoke a class static variable.
Yes,
right?
which Java technically allows, though I think I mentioned in lecture, I think that was a bad call because it leads to code that's confusing.
So for the test, we should be basically talking about how it's missing the instance name so that it won't.
No, I mean, that's not a bug. The issue on the test was that if you have a static variable, then there's a single size value that's shared by all possible S lists.
Oh, okay.
Does it make sense?
Yeah, it does make sense.
Yeah,
Right.
it's a subtle, it's a hard question. It's on the hard side, but yeah.
Thank you.
You got it.
Sorry about that. But just a follow-up question.
Yeah.
So so it's just not possible if we change it in the instance calls, then the size is going to be changed, right?
You change it in the instance calls.
Instance method calls.
Yeah, it will be changed. Yeah. So whatever that number is, it does actually get changed. Yes.
And we don't have to do that using the instance name. We can just call size.
Yeah, you can just say, size equals size plus 1, for example.
Okay.
Yeah.
And that's when it's declared static. We can still do that.
Yeah, even because the static variables, they could be accessed without saying this dot.
Okay.
Yeah.
Sounds good. Thank you.
Got it. All right, Ben.
Yeah, so you were kind of showing this issue with the integer sort list. But I was running into probably a similar issue on testing my max array deck. So I'm wondering, when we write those, the comparators for our tests, should they be like, I want to compare integers, so should I do like, should I make the class of my new comparator as a comparator integer or just comparator t?
Well, you can't actually make something that's a comparator of t's. If we look at, oh, oops, okay, good. One second. Okay. I'm going to open up the other IntelliJ. Okay. So here we go. So you're saying you ran into something kind of similar to this, and you're wondering if you should make your thing a comparator of t's?
Yeah.
Yeah, I mean, you can't just make something that's a comparator of t's. We got to figure this one out.
I mean, it works in the test, but it's weird because I have to like cast those t's to integers once I want to do something.
Got it. Let's see. So you have some kind of weird cast. Do you want to send me a quick email with an example of your cast, and I will look at it, see if I can sort it out?
Yeah,
maybe it's not worth putting in here.
Thanks.
Yeah, please do. Someone asked, is there a way to fix white space automatically? So you should be able to do, I mean, I'm surprised if it's not the case that the default, let's see, the default spacing isn't the right amount. Like you should be able to do something like, where is this thing? Code, auto indent? I thought it was refactor. I'll try auto indent lines. Is it auto indenting that's the problem? Or is it somewhere else, Consuela? I'll wait for a response in chat. All right. Sorry, I keep forgetting if it's Dana or Dana.
Dana.
Dana. Okay, go ahead.
No,
I'm
okay,
Dana, so it's like, yeah, she trained me. Go ahead.
Yes, so I had a question about like higher order functions. So if we have like interface called like comfunc or something, I think I found this in like a midterm problem or something like that. But we have a class that implements that interface, and then it has an apply method, and then we can pass it to some other classes method to use that actual like apply method. So if like, for example, if the class I was talking about was like add and it had like the apply method, if we made the public class a static class, like the add class a static class, then would you just pass in add instead of a new instance of add?
No. So the question is, if it's a static class, do you have to instantiate? You still have to instantiate it. The only thing that's special about a static class is that it doesn't have a reference back to its enclosing instance, right? So like if you have an example of a static class would be like a node class in a linked list, and you make the node class static, then you can't access the overall linked list's variables from a single node instance. Does it make sense?
Okay.
Maybe.
Okay.
Maybe.
So,
Yeah, but to
that
answer
makes
your question less bizarrely, it's just that if a class is static, you still have to instantiate it to use it as a comparator or whatever else, or an adder or whatever else.
So then what is like the point of making a class static then?
An instance of, the main reason is an instance of the static class requires less memory because it doesn't need to have a pointer back to its enclosing instance.
Okay.
So imagine if you have
Okay,
nodes in a linked list, it means that every single node has to have a 64-bit pointer back to the overall list. So it makes every node a little chunkier. That's the main reason to make a class static. The other thing is also a reminder that you shouldn't be touching the external class's instance variables or methods for that matter.
Okay.
So basically, sorry, if the nested class is static, it kind of can't look outwards. It can't look at the size of the list that it's in. So it's also a constraint on the programmer.
Okay.
Yeah.
Okay. Thank you.
You got it. Austin.
Hey, is it all right if I ask a midterm one question?
Sure.
So with the reverse, was it as simple as just like traversing backwards, removing the item, and then adding it to the end?
We don't have to traverse anything, right? Because on the, let me look at this test. Yeah. So if we go to, this is MT1 list, is that right?
I think so. I think its signature was just like reverse parentheses, parentheses.
Yeah, but it's part of the MT1 list, not the BLL list class.
I think so, yeah.
Wow, it's being slow. Yeah, I mean, you can't traverse anything because you don't know what kind of MT1 list you have, right? I mean, you have these methods. So when you say traverse backwards, what do you mean?
Oh, sorry, I just mean like a for loop that's decrementing from a.
Oh, right.
size.
Yeah, there's a few different ways to do it. I mean, so you're saying having a for loop. Go ahead, walk me through your thinking.
Yeah, so for loop starting from size -1, decrementing down to 0, and then 3 lines inside the for loop.
Starting where? At size -1?
Yes.
Okay, and then you go down to 0. You might butt off by 1 or so. You have to kind of think carefully about these. I don't know, I minus. I'm not sure exactly. We can think about the corner cases or like the exact bounds in a sec. So then you're saying do what?
T removed equals get I.
T removed equals get I. Yeah.
Remove I.
Uh-huh.
And then add last removed.
Add last removed. Okay. So if you do this though, let's see, do you run into trouble? Because you're starting at the end, and when you remove the item, then it's out of the list. Oh, but is it the end? Oh, I gotta think about it. Okay, so if we actually tried this, let's just try it. But again, the bounds here might be slightly wrong, but let's say we had A, B, C, D, E, F. Okay. So if you do this, and we start at index.
Did you intend for us to see your screen or no?
Yeah, I do. Thank you. Okay. There you go. All right, so I basically just wrote out the code you gave me, and this is the bound that I don't have my phone. Usually I have my phone on, and I can like look down and see what's on the screen, but I didn't.
Just one small tweak. Add I is greater than or equal to 0.
Okay, got it. I just don't know what the exact bound is. Yeah, I was saying I might be wrong, but I was just lazily transcribing. So if you do this, you're going to get item 5. So we'll have remove this 5. Then we're going to remove it, and then array becomes this, or the list becomes this. And then we do add last F. So it looks like we end up with A, B, C, D. So that operation didn't do anything, right?
Mm-hmm.
So that seems not good. Then we do what? Remove, but it might work. Okay, then we do remove 4. Okay, or remove does not, I should say remove 5.
Can you zoom in, please? Sorry.
Yeah, sure. Thank you. There you go, better?
Yeah, thank you, sorry.
Sure, no problem. Please always interrupt me on this sort of things because I can see fine, you can't. So if we do this, we get A, B, C, D, F. Then we do add last E, and then we get A, B, C, D, F, E. Okay, well, that's a good sign though. Looks like it's gonna work, I think, right? There's a lot of different ways to do it. I think mine was recursive, so yeah.
I was just worried because like my closing brace would be on line 9. It said like the solution was on 11. So I was like, are there some?
I think it's because we wrote a recursive solution because it was more obviously correct.
Okay.
So if we do remove 3 now, that's good. D is the next thing that's supposed to come. Yeah, actually, this looks a lot like my original. Yeah, because you can start at 1 less. Oh no, actually, you know what I did? I removed the front item over and over, but I think this works fine, probably. So add last. Let's actually work it out. So E goes away. Add last E. A, B, C, D, F, E. Yeah, you can just tell it's going to end up being F, E, D, C, D, A, unless the bounds are slightly off. All right, looks good. Yep.
Thanks.
Yep, cool. Yeah, there are many solutions to this. There may be a 3-line recursive solution. I don't remember, right? Yeah, because I had all these problems in my brain over the course of many weeks. So maybe it was that the recursive solution was even shorter. Yeah, I don't remember why mine's longer, but let's see. Oh, the white piece question. Adding space between parentheses, commas, after brackets, and like. There is some way to do it. I don't remember how to do it. but I'll look into it and let you know next time. Yeah. Let's see. Okay. Shrista.
Hi, Professor. So
Yeah.
I had a question on, sorry?
Okay.
Yeah, I had a question on midterm 1 again. So the question about, what was it? We wanted to remove from the start index to the end index.
Oh yeah, right.
Yeah, so for that one, would we have to consider like the edge cases and stuff? Like if you keep iterating through the MT1 list, then like you would have to like decrement the end variable so that it didn't keep on removing everything.
Like you're saying if n was larger than the remove, basically? Like if you had a list that was like A, B, C, D, E, F, and you did remove start like 3 and end like 10? Is that what you mean?
Well, I mean, if you just had like remove 1 to 3, right?
Yeah.
And you kept on mutating this list, right?
Yeah.
Would you, if you did it just normally with the for loop, and then if the index was between 1 and 3, would it just keep on deleting after 1 because the index keeps on coming back down to that range?
If you did like a recursive call, are you saying, or?
If you did a for loop or like a while loop.
So if you did a for loop, I mean, I think it is possible to write a for loop. I feel like you're saying there's a naive solution or like a intuitive solution with a for loop that has a issue, which is that you're doing. Oh, I think maybe I see what you're getting at. If you do for int I equals start, I is less than or equal to end, I plus equals 1. Yeah, you'll run into trouble if you're calling remove on I, because what you'll end up getting is A, B, C, D, E, F. The first delete will be fine, right? You'll get rid of B, then you'll have this. But then of course, the place where everything is different. Yeah, that's exactly right. Yeah, so you'll need to take into account the fact that the next item you want to remove is also in position 1. So you'd actually want to be like doing remove start or something like that.
Okay.
Make sense?
Yeah. Was the
one way to
solution
do it.
for this one written in like, was it recursion or iterative?
Doubtful. No, I'm pretty sure it's iterative. It's you can't. I think it'd be quite awkward to do this. You can't really do this one recursively because of the return here.
Okay. All right. Thank you.
Yeah. Yeah. Cool. Someone else said they did start minus n for the return condition. Yeah, you can also do something like that too. Like start I at 0, do start minus n, remove start. Yeah, that's the same thing. It's just less obviously correct, but maybe you argue it's just as correct. I don't know. Adam.
I guess I have another question about the midterm. For
Sure.
the question where it had the interface, I think it's empty list as well.
Yeah.
If you wanted to create a list, because you can't instantiate an
Yeah.
interface,
how
would you go about it? Is it possible to use, would you like create a pointer with midterm list?
Well, so the intention was you would call create list up here. So we just have a function that does that for you. So, I mean, that's one way to do it. Make sense? That was the intention, at least. Sorry if that was mysterious.
Okay. No, I just did it in 2 lines, but I don't know if that changes anything. I did mtx like semicolon, and then in a new line x is equal to, yeah.
Oh yeah, that's totally fine. That's exactly what we intended. Yeah.
Okay.
If you didn't have this create list, this is actually a contentious debate. What I used to have it is I said, assume you are given a specific implementation of empty1 list called an x list, and then you did something like x list t, x equals new x list. And then at the end you return x after you do stuff with it. But it's kind of weird because this is only some specific type of list. So my TAs convinced me that this was better to have it create empty list. Yeah. What's sort of weird, it's like if you want to make an empty1 list that's the same type as the current list, you have to do some really weird stuff. Some big brain stuff, galaxy brain stuff, as we put it. Like you can do, you would have to say this and use this library that you've never seen, where you would say like get class dot get constructor dot that got instance of, or something like that. Yeah, there is something you can do like that, but I will not teach you how to code like that because it's almost always horrible style. But if you wanted to, you could. Yeah. Anyway.
All right. Thank you.
Cool. There's no questions right now. Should we try and figure out that type error? Yes. I want to figure it out. I'm frustrated by this dumb thing. Okay. We got 5 minutes. Okay. Sorry, whoever's watching this later, because this is not necessarily a good use of your time, but you can fast forward till we get it. All right. Arrays.sort. We got a 7 count. All right, I'm going to do something real quick. I don't think it's anything to do with the fact that it's integer. But oh, wait. Well, no, it should be fine. It's a comparator. It returns an int. It takes integers. This should be fine. But I'm going to do something real quick just to see what happens. Wait, all right, I'm going to move this out of this class. We are in collect 10 inheritance 3. Okay. So I want to do this in another class. Other class. All right. So I'm just going to do the exact same thing here, except I'm going to make a copy that's string based. I'm 99% sure this will not be helpful, but
It's on your browser.
Oh yeah, thank you. Okay, you can't see what I'm doing anyway. Okay, we're gonna do it. We're gonna do it. All right, sum comparator for strings compares strings. Okay, great. Who cares? Test count. Sum count string s. I don't care about what you actually do. I just want you to return 0. Okay, great. We don't care about this test either. And we take string and a string. Okay. And now if we go to other class, okay, so string a equals hello. Guys. Okay, sort a new strings. I'm just ruling out one possibility for what's going on. All right, it wasn't that possibility. Good. Okay, because this would have really broken my mind. Okay, cool. So we're in good territory.
Wait, I'm sorry. I kind of came a little late. What's the problem, or like what's going on right now? Sorry.
Earlier we wrote some code where I wanted to show off how cool it is that you can write a comparator for integers and then sort them by the number of 7s in the integer. Should be straightforward. Now, when I actually tried to use this in my demo, the compiler was yelling at me and saying, sorry, you're supposed to be giving me a comparator for integers, but you're giving whatever. It's like the type checker is yelling at me in a way that doesn't make sense to me.
I see. Okay.
Yeah. For type variable t. Why can't you do it? All right, hold on a sec. All right. So we have a more general problem. Arrays, sort, custom, comparator. Okay, I'm gonna share my whole screen. Okay, any kind of. Okay, here we go. What am I doing wrong? Okay. Salary comparator. Okay, well, I have another idea. Nope, that's not the problem. What on earth? 1 minute. That was so bad. Okay, oh, I got an idea. Let's make, I want to see if this works. Comparator integer t, c equals new 7 count comparator. Okay, that's fine. It is actually 7, okay. I'm giving you one. This is an integer, it's a comparator that compares integers. Oh. All right, anybody spot the bug? So in this lecture, for fun, I created an interface called Comparator. It's not the real comparator. Everything was fine the whole time. Okay, hold on a second. The problem was that I created my own comparator interface. Okay, let's go in a different folder. Wow, my mind was really broken there. Okay, hold on. Let's run things yet further. Okay. 7 count comparator. Wow. All right. Always something really dumb, isn't it? Okay. I want to sort these integers. I need to have these integers sorted. I'm not willing to live with this insanity. Okay. Blah, 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 blah. I wish. I'm so glad we got it. Okay. Okay, you're not allowed to exist. We're going to go over here. We're going to do it in this other folder where I haven't created my own comparator. And this time, oh, no, that doesn't make sense. Okay. New 7 count comparator. Huh. Oh, the same bug. No. Unless. I thought I had it figured out. No. Okay, I guess we're going to figure it out next time. All right. Sorry, everybody who watched this video. The saga continues. We did break Java. Okay. I was still imprinting the wrong comparator. Yes, you're right. Okay, thank you. Here we go. Oh, what's a comparator? We got to import it. Okay. Yes, there it goes. We did it. We did it. Okay, hold on. We got to print this thing out. Actually, we used the visualizer so we could see it happen. I've never been so happy in my life. Okay. All right. Java visualizer. Hard to use the debugger whenever you are having compile errors. I step over and look, they're sorted by the number of 7s. Hooray! Everything's exactly as it should be. Okay. Starting now, there's a town hall on the new CS declaration process. I'm going to go to that. So if you want to hear me talk about it, I posted a link on Ed. Thank you, everybody. I'm so glad to have that closure. Let's see. Here, I'm going to put the thing in the chat real quick. Town hall. Okay, so yes, I'll see you there if you want to go. We did it. We did it. We did it. I'm so excited. All right. Bye, everyone. See ya.